Have you heard about IVF test? No, not that IVF test. This IVF test is about the laboratory and clinical procedures used to evaluate your reproductive health before and during in vitro fertilization. It's a series of checks and balances to ensure everything is optimal for creating an embryo and hopefully seeing a successful pregnancy. From a biomedical engineering standpoint, IVF testing involves diagnostic assays, imaging technologies, automation systems, and biological sample handling devices. Let's start with the key tests. First, hormone tests like FSH, LH, AMH, and estradiol to evaluate your ovarian reserve and help time your IVF cycle. These are typically done using immunoassay analyzers, which can be miniaturized, using biosensors or microfluidics for rapid and accurate hormone detection. Next, ultrasound scans to assess the number of ovarian follicles and the thickness of your uterine lining. This is done using a transvaginal ultrasound probe, which generates images that can be processed to create a 3D map of your follicles. We also perform semen analysis to check the count, motility, and morphology of your partner's sperm. This is often done using automated CASA systems, which utilize imaging algorithms and fluidics to analyze sperm parameters. Another important test is the hysterosalpingogram, or HSG, which checks the patency or openness of your fallopian tubes. This is done using an X-ray and contrast agents, which allows for real-time visualization and image processing to analyze the structure of your fallopian tubes. Additionally, we may perform blood and genetic tests to screen for infections and hereditary disorders. These tests include PCR machines to amplify and detect specific DNA sequences and DNA sequencers to determine the order of nucleotides in a DNA sample. These instruments are often integrated into lab automation robots to streamline the testing process. Now let's talk about how biomedical engineers contribute to IVF testing. They design, improve, or maintain key IVF lab equipment, such as incubators, which are used to maintain precise temperature, CO2 levels, and humidity for optimal embryo culture. They also work on micromanipulation systems, like those used in ICSI, which injects a single sperm into an egg using high-precision robotic arms and microscopes. Biomedical engineers also develop time-lapse imaging systems for non-invasive embryo monitoring and AI-based embryo selection. They also design cryopreservation units for storing eggs and embryos in liquid nitrogen and lab information systems, or LIS, to digitally track patient samples and results to prevent mix-ups. Finally, bioengineers are working on innovative point-of-care diagnostics such as Labanocum devices for rapid fertility, hormone analysis using a minimal blood sample, and AI-based sperm and embryo grading to improve the prediction of success rates. They are also exploring non-invasive embryo assessment by detecting metabolic biomarkers in the embryo culture media instead of invasive biopsy. Additionally, wearable ovulation trackers that continuously monitor hormones and temperature to identify the optimal time for IVF are being developed. So that was a quick overview of IVF testing from a biomedical engineering perspective. Stay tuned for more videos on IVF and other exciting topics. Thanks for watching.